Densitron produces specialized human-machine interfaces linking high-quality displays and human input devices with computer capability, and application software for integrating third-party devices into easy-to-use control and display systems. This video describes Aurora SBX and ASE, or the Aurora software ecosystem. Together, these create Densitron's all-in-one plug-and-play solution for display-to-computer board connection. Densitron's Aurora boards, together with Densitron's Aurora software ecosystem, or ASE, provide a simple and easy way of connecting computer boards and displays together to create ready-to-use computer-driven monitors. By using these purpose-built plug-and-play components, significant time can be saved in enabling and configuring the connection between the computer and the display. Aurora with ASE can be used with both touch and non-touch screens and can be supplied as a kit, as part of an open frame mechanical assembly, as part of a closed frame mechanical assembly, or as a fully compliant and certified Densitron control surface product. Control surface products from Densitron that already have Aurora and ASE integrated include the 2RU control surface, the 2RU control surface with physical on-screen buttons, such as the 18-button and 54-button configurations, the half-rack 2RU 8-inch control surface, and the Tactila evaluation kit. Aurora and ASE can also be easily integrated if required into Densitron's x86 control surfaces, such as the TS10.1 and the TS16.3. Let's overview each of the elements. Starting with the Densitron Aurora SBX board package. A complete Aurora package comprises a Densitron computer board preloaded with a stable board support package connected to a display-compatible Densitron adapter board, and both preloaded with Densitron's DensiID software. This assembly then connects directly to one of Densitron's high-resolution TFT or AMOLED displays. The Densitron computer board range includes a Linux or Windows-compatible computer, a microcontroller board, or a microprocessor board. Options for the Densitron adapter boards allow for all standard interfaces such as LVDS, RGB, MIPI, or EDP. Moving on to ASE, ASE provides a Linux-based virtual machine environment running on Linux or Windows, in which changes can be tested on the display prior to code compiling. This includes a ready-to-use Qt Creator GUI interface for easy development of the display content, plus access to free-to-use examples of display content from the Densitron cloud. ASE operates on a virtual machine over local area network, so developers can work remotely from the display. It also supports cross-compiling, which means that it is possible to update a display design remotely and to see the result on the display itself in real time, eliminating the need for regular compiling and saving a great deal of design time. Here is a network diagram of the current ASE solution. A future release of ASE will offer new benefits. Through the Densitron cloud, it will be possible to upload and distribute display designs and receive and send software updates to devices and remote sites with either automatic or manual deployment. In combination, Aurora with ASE provides a powerful way of integrating displays and computer boards. In tests, development engineers were able to assemble and install the Aurora and ASE combination in less than an hour, creating a fully integrated and working computer-driven monitor. Experience suggests that an equivalent display system without this combination can take from several weeks to several months to build. We will now explore some of the basic features of the Aurora SBX boards with ARM processor. The ARM versions of the Aurora SBX boards are currently available with IMX6 or IMX8 core processors. The standard IMX6 architecture, shown here, is a single board computer. Alternatively, The standard IMX8 architecture offers a Q7 form factor SOM-based architecture and comes with a carrier board driving Densitron's 2RU display. Custom options of both the IMX6 and IMX8 boards are possible and can be built to suit customer-specific input-output requirements, space constraints, and thermal requirements. For customers needing to get their product to market in the quickest possible time, the IMX8 SOM-based architecture allows for a faster custom build time. The IMX6 Aurora SBX board, shown here, features either a single core with 512 megabytes of RAM, a dual core with 1 gigabyte of RAM, or a quad core with 2 gigabytes of RAM. Here you can see the principal elements labelled: the industrial embedded computer, the RAM, the SD card boot storage, an Ethernet port, an HDMI connector, 2 RGB LVDS display connectors, a MIPI connection, an expansion socket, a USB port, a microphone input and output, and a power supply connector. The alternative IMX8M Aurora SBX board features a quad core with 3 GB of RAM and 16 GB of eMMC storage. To show the ease with which the Aurora ASE can be set up, one of our developers demonstrates here the process for installing the ASE software. First, download and install VirtualBox. Then log into the Densitron support portal and download the Aurora software ecosystem. Now create and run a virtual machine. Once you are into Aurora ASE, set up the network, select your language, and configure the system. Open Qt Creator and initialize. Finally, create and deploy your screen design to your displays as shown here. Here to the right-hand screen, And now to the left-hand screen. Congratulations! You have now deployed your first display design. We hope you have enjoyed this video. If you need any further information, then please do not hesitate to contact the Densitron technical sales team.